So very, very accurate measuring is the most important topic in especially things like university physics, especially once you get to master's level and so forth. So we need to start the basis now, and even before now if we can. Okay, so here's how not measuring absolutely correctly can actually change your whole measurement structure. So I'm going to show you guys a video about that quickly. This is called the parallax error. Here we go.
Okay, let's talk about parallax errors. Parallax
Please let me know if you
are
can't hear.
errors that occur depending on how we look at a device. So when I look at this device here, let's just say I want to measure what is the mass of this object. So I'm just going to zoom in here and see what we get. But let's just say I'm sitting at the lab bench and I don't really feel like being in the front, so I'm just kind of over here. If I look at this device from over here and try to take a reading, I'm going to zoom in here. I'm going to say this looks to me like the answer is about 2.41 grams. Now, if I were on the other side here, and I looked at it.
Is this better?
I say, no, you know what?
Hope so.
That looks a little bit more like maybe 2.66 grams. And neither one of us is correct. The best way to circumvent parallax errors is to look at something front and center, which is fairly obvious, but sometimes you forget it. So let's just think about this here. If I look at it from the straight and center, what I find is that looks like it's about maybe 2.56 grams. Now, so the main way to avoid parallax errors is to look at things straight and level. Parallax errors basically are caused when you look at things from an angle. Now, if I was to look at, say, this here, and I look at it and say, well, first of all, I can look at it straight and level. If I look at it straight and level, what I find is it looks like I've got about 21.38 centimeters. But the problem is if I go over here and look at it, now it's like, oh, look at it over here, I'm already up to 22 centimeters. And if I look at it from over here, it's down to about 20.5. So as always, the answer is to look at it from above, from straight and level. But one thing I want to point out is another way of reducing it is by getting the device in question as close to the measuring device as possible. Look what I'm doing. I'm going to lift this up in the air. Now look how much difference I can get when it's up in the air, far away from what I'm trying to record. So the one way of reducing parallax errors is to get the measuring device as close to the thing I'm measuring as possible. So watch what I'm going to do this time. I'm just going to move this up onto its edge. And what I find is when I do it this way, there's really very little room for debate. When I look at it this way, what I find is it is 21.47 centimeters. The closer I can get the closer I can get the tick marks to the thing I'm measuring, the less likely I am to have parallax errors. Parallax errors are caused by looking at things from an angle, circumvented by looking at things straight and level, and keep the things as close together as possible.
Okay. So in that video, he showed you what we mean when we speak about something called a parallax error. A parallax error is an error in measurement made by not looking at it correctly. So nowadays we try to circumvent parallax errors mostly by starting to use more electronic-based measuring equipment, especially in science labs. However, at home, we don't tend to have very fancy electronic measuring equipment and things like that. So what you need to know is in your experiments, in your scientific experience, even when you're baking a cake, to try to minimize parallax error as much as possible by trying to get the measuring little scale as close as possible to what you're actually measuring, and B, to get right up close to what you're looking at and looking at it straight ahead. If you are trying to look at, say, a measuring jug, let's pretend my cup over here is a measuring jug. If I try and put it down and then look at it from above, well, the reading I'm going to get is going to be vastly different than if I put it down on the counter, get my head down next to it, and look at exactly what the mark would be on the side of the measuring jug. So the thing I'm trying to emphasize here the most is to try to be as accurate as you possibly can when measuring things that you need to measure. So I'm going to show you another video. So here is how to measure liquids. I realize it's soft. There we go. Okay, so that one was trying to show you the parallax errors that you can get when measuring liquids. So there's one very important thing when measuring liquids, and that is to look at what they call the meniscus of the liquid. So what I mean with the meniscus is if you pour water into a glass and you look at the edges of the glass, you will see that the water, while it's nice and flat in the middle, tends to just rise up slightly close to the edges. And that is what we call the meniscus. If we want to take an accurate measurement, we don't want to measure there where it just slightly goes upwards. So we don't want to measure that but there, because then we're going to not get a very accurate measurement. We want to measure where it is flat. So we try to measure at the bottom of the meniscus. Okay, water does that due to the attraction that particles have to each other. So the same way that the earth attracts us to it, the same way all matter attracts each other. So this is not to say that a girlfriend and a boyfriend or anyone in love actually gets attracted to each other due to the fact that gravity is at work. It's not at all. So what I mean to say here is that if we look at an atomic level, then the water molecules that we have inside the glass will be slightly attracted to the glass itself, and that will pull the water up just slightly at the edges of the glass. And that would in turn cause that meniscus to be shown. There are certain liquids that are less attracted to the glass that you pour it in than to itself, like mercury. So since we did have this question, I am going to quickly show you something about that. So water meniscus. So this is what we mean with a meniscus of a liquid. If you look over here, you can see that it starts dipping down towards the center. So if we look at something that has a bit of a more flat surface, say like a glass over here, you can see it tips up just slightly towards the edges, but it's mostly flat in the middle. All liquids, to some sense, have a meniscus. So now, instead of looking at water, I am going to look at mercury. So here we've got some water, and here we have mercury. What mercury does is it's more attracted to itself than it is to the glass that you've poured it in. And so we end up with its meniscus being upwards instead of downwards like it is for water. Okay. So yeah, it is slightly strange. It's a very interesting property that we have for liquids, but it is what it is. We can't really change that at all. So what was I busy with? Right, liquids. So you need to measure right at the bottom of the meniscus in order to get as accurate a measurement as possible. So we've talked a bit about measuring length, which they had in the first video. I'm not going to talk too much about measuring length using a ruler. You should have had lots of practice with that throughout your primary school career up to now. Lots of practice. Okay. Measuring liquids, you do need to practice in a sense. So what I would recommend there is if you are measuring things for baking a cake or for cooking or anything where they say you need a certain amount of liquid in it, try to measure it as accurately as possible as a way to practice. You don't need to do it too often, just keep your measuring skills up to par. What's a ruler? Okay, so let's go back over here. A ruler looks like this. And it is literally just a long bit that you can use to measure distances. So I'm not going to talk about a ruler much. I'm instead going to talk about a vernier caliper. Okay, so a vernier caliper is a kind of ruler that we use that is way more accurate than just a ruler. A normal ruler you can measure to the closest millimeter or maybe the closest half millimeter if you're very pedantic and pushing it. But if we use a vernier caliper, we can measure up to hundreds of millimeters if we have the correct vernier caliper. So I'm going to show you a video about vernier calipers. So here we go.
Bob Welch, and this is how to read a metric vernier caliper. There are different kinds of vernier scales designed to do different jobs, but they all work pretty much the same way. Today, we're going to look at a metric vernier designed to measure to the nearest 1/50th of a millimeter. That is 0.02 millimeters. See how 1 divided by 50 equals 0.02? Now, the first thing we're going to measure with our vernier caliper is nothing. That's right, we'll measure 0. It may sound like a silly thing to do, but we're going to do it for a couple of reasons. Let's do it and you'll see what I mean. You see, when the calipers are fully closed, measuring 0 width, you can see the places where you can take measurements. These surfaces are where the two parts of the calipers line up. You'll also notice that there are gaps in a couple of places on the calipers. These are not places to take measurements, so don't mess up by putting something in one of those gaps. Now, with the calipers closed, you can see where you're supposed to read the main scale. There are two scales on a vernier caliper, the main scale and the vernier scale. I'm going to erase the vernier scale and let you just look at the main scale first. You see, the 0 mark points to the place where you're supposed to read the main scale. Right now, it points to 0. Do you see that? Good. Let's read the main scale first. It's super easy. I'll close the calipers on this workpiece and we'll see what the main scale says. These marks represent whole millimeters. So the reading is 1, 2, 3, 4, 5 millimeters. Just be sure to look at the 0 mark and not at this part. That's a common mistake, and it'll give you the wrong reading. So the reading is 5 millimeters. That's pretty easy, right? Before we move on to the vernier scale, let me show you what it's going to tell us, okay? Let's say when we looked at the main scale, the reading wasn't right on the mark like it was last time. Let's say it looked like this. See how the mark is between 5 and 6 millimeters? It looks like it's a little beyond halfway. You see, the vernier scale is going to tell us almost exactly how far over the mark is. Okay, you're ready to see the vernier scale, but I'm only going to draw the main part of it first. Now, you see the marks number from 0 to 10. Each of these marks represents a tenth of a millimeter. They're going to tell us the tenths of a millimeter, and here's how they work. Look carefully, and you will notice that one of the marks on the vernier scale lines up better with the main scale marks than the others. Which one looks like it lines up best to you? I'll zoom in and let you look. Let me show you a hint about where to look on the vernier scale to see where the marks line up. You see how our pointer was a little more than halfway between marks? That means the vernier scale will line up a little past halfway. Now, do you see the mark that lines up better than the rest? It looks like the 7 is lining up. The 7 means 0.7 millimeters, but this caliper can measure even more accurately than that. I'll redraw all the marks and let you look again. Now, see that the mark next to the 7 lines up best. But what is the value of that mark? Remember how this caliper had a label that said 0.02 on it? That is what each mark is, 0.02 millimeters. Let's count up on the vernier scale to be sure we've got it. This 6 would be 0.60, the next mark 0.62, then 0.64, 0.66, 0.68, 0.70, then 0.72. The reading is 5.72 millimeters. Pretty neat, huh? I'm going to let you try a few. We're going to start off easy. I'm going to draw a caliper that only reads to the nearest tenth of a millimeter, just to be sure you're with me. I'm going to show you the overall picture first, then zoom in to let you see the vernier better. Okay? When you see Sparky's pause the video and write down what you think the reading is.
Okay. I'm not going to show the rest of that video because the rest of that video is more just to practice it. I will post the link of that video in the chat afterwards so you can practice it on your own. The last thing we need to talk about is measuring weight or mass. So on Earth, the measuring device we use for mass is a scale. And an ordinary kitchen scale will do perfectly well. The only thing you need to know about measuring weights or mass is you need to remember to subtract the container's weight from the total weight that you're measuring. Most modern scales has something called a tare button that you can press in order to zero the scale before measuring, and that will do that for you so you don't need to worry about subtracting the container. Old style kitchen scales, however, don't have that, and you either need to turn a dial on the side to manually zero it if you've added the bowl on top, or you need to measure the bowl, then add the things into the bowl and then subtract the bowl's weight. So that is pretty much it for today. In terms of vernier calipers, you really don't need to get one, not even in A-levels. I am 90% sure you don't need to get one in A-levels. If there is any kind of Cambridge school close to you that you can do your A-levels or so practicals at, then you don't need to get one at all. You can use theirs when you go in to try and do your practicals. The 10% depends upon where you live. So if you don't live close to an actual Cambridge school or something where you can go do your practicals, and you don't have anything like a science lab nearby, then you may need to get one. But knowing how to use one is the most important part at this point. So I am going to go back to this very quickly and show you the whole part of the vernier caliper first. So this part of the vernier caliper over here that he put, you don't need to worry about having a lab nearby. It's not for this level at all. It's only if you want to do the practical portion of your science class. So don't worry about that at all. Over here, in between these two sort of jaws, is where we will place something if we want to measure its outside diameter. This bit over here is what we use to measure its inside diameter. So here, he moved this away so that you can actually measure this outside bit. Trying to see if he has another picture over here. Nope. Okay. So, yeah. He makes fairly cool science videos, but okay. So this bit is where you measure outside diameters. This bit over here, the jaws actually move past each other so that you can measure the inside diameters of objects. If you look at this picture over here,
Remember that degree you got in taxation?
I really hate ads. Okay. If we look over here, you can see, whoop. Here. You can see these move past each other to measure the inside of objects. There's another part of a vernier caliper at its base, and that is to measure, so that would be over on this side of the caliper pushing out, and that would be to measure the depths of objects.